Hey, just kind of randomly decided we would see how far we can get getting the Cursor IDE installed, getting Extism, you know, ingested into the system, see what the LLM can do, and who knows, we might be in for a treat. We might be in for some disappointment, but nonetheless, we're going to be writing some code and having fun. So yeah, I just randomly kind of have a bit of a free day, and yeah, I'm excited to see what this whole cursor thing can do. So for anybody who has had their fingers in their ears for the last couple of months, you may not know, but there's all these IDEs and AI copilot technologies that help you write code, and Cursor is one of those, apparently a really good one. And so off camera, I've already installed it, signed up and signed in to the editor, which feels strange, but why not? We've got Extism loaded up in Cursor, and let's just kind of see what we got going on here. I've already imported all my extensions and stuff from VS Code. I do use VS Code alternatively. I'm just going to walk through, I guess, some of their like getting started things. Okay, so it wants us to accept an autocomplete. Okay, well, first of all, like, what are we going to build? One of the things that I recently discovered, let's just bring Extism back up here and show you maybe the Go PDK. So when we log things from Extism, you're writing a plugin, you want to get some of that output from the plugin written to some log file or some log output based on some, I need it to only reach, debug thresholds or error thresholds, etc. We have these logging functions, and Extism log info, debug, warn, error, etc. All are imports that the runtime provides the PDKs. And so from the plugin developer's perspective, they're just kind of writing normal Go code or Zig or Rust or whatever. And when they call one of our logging functions, which are usually wrapped in some convenience layer, they're actually calling this log debug import and allocating some memory and passing the offset to that memory up to the runtime, which then in turn reads that memory, loads the bytes from it, and then flushes them to wherever the log destination is. So, okay, the problem is that when we actually call this function, and I got to show you the convenience layer here. So we've got these log types. We're going to run, let me bump this up a little bit so everybody can see it. So we call this log function. It takes a log message, and we immediately allocate that string. This is usually fine. Like, the allocation's fast. Log messages are usually pretty small. But we have recently put out some new things that are yet to be shared widely. So here's a little peek. But we've kind of released our own kind of code gen layer for bindings. You could consider it like a component model to wrap your WASM in more idiomatic functionality to copy things across the guest host boundary. And as part of this, we've kind of plumbed through some just automatic logging as a convenience for a lot of these kind of code gen templates. So for example, inside one of the templates, it'll generate exports for you and kind of wrap these exports in more convenient functions that'll take like rich domain types, and you could pass them as input to the function and return rich domain types versus WASM's primitives or Extism's beneficial but low level bytes in, bytes out interface. So inside of this generated export, we're going to write this log here. And in most cases, the input to the log function is pretty small. Like this is a fairly minimal allocation necessary. However, they can get a little bit big. And in one case, maybe not here, I decided to actually take the full output that comes out of the implementation function and write it to the log implementation. And what I realized, this is like slowing down the execution of the module quite a bit, because we just immediately do the allocation. We don't first check, okay, what's the log level? Should we allocate if debug meets the criteria of the runtime who set the log level for reporting? So anyways, hopefully that gives a little bit of context. What we ultimately want to do is in our PDKs, have some functionality to call into the runtime and say, hey, what's the log level set by the host? And if that log level means that we should actually run one of these functions, then only at that point do the allocation. So we would want to check first around here, guarding this function call, that we should actually do the allocation before we write to the log. So what that means is we actually have to add some code to the runtime. And the code to the runtime is a function that should basically store the log level that was set by the host, the operator of the plugin system that wants to call plugins. So yeah. By the way, forgive me if I start to ramble. This is totally stream of consciousness, like just trying to get a grasp of how this AI tool could help, if at all, and then also maybe get something productive along the way. So please feel free to drop questions in the chat. Would love to hear from you. Call out anything you think I'm doing wrong or the AI hasn't caught yet. And I'd be happy to stop and add more detail to anything. So yeah, let's start by looking at this runtime directory. In the runtime, we've got a bunch of stuff that kind of make up all the internals of Extism, and also end up partially making their way into this feature we call the Extism kernel, which is a WASM module that provides runtime functionality to almost all of the Extism SDKs. Just basically lets us reuse a lot of things that we would otherwise have to rewrite in a bunch of different host languages. So we get to compile all this stuff to WebAssembly and execute it inside a runtime like Y0 or WASMtime or Whammer. And we just get the portability of not having to like rewrite a bunch of things. So aside from that, there's this file here, which defines the functions that get provided as imports to plugins. So for those who are familiar with the plugin interface, you can do things like call HTTP request, which is an Extism provided module that gives a plugin the ability to call out to a host approved network and make an HTTP call. We're focusing on the log one here, and this gets called by the host when they want to define like what log level do they care about. Sometimes this materializes in the Extism CLI. All right, so here we go. This is basically VS Code. We have the Extism CLI, and one of the features you can pass it in its call subcommand is log level. You do this programmatically in your like SDK if you were implementing a plugin system inside of your application. But so for example, we have a log level set, and you can set it to any of these values, and that will give us log output at the CLI. And so when you pass this log level, this function gets called by the SDK, which pokes the runtime and says, hey, allow logs that are at this level, or below in terms of its verbosity to be collected and then written to whatever defined output. So in here is kind of where we want to somehow store the level. And in fact, it may even need to be higher because this seems like it's the function that's called every time. Because we have an input here. Perhaps not, because we also have, yeah, it is. Okay, so every time one of these functions are set, we call this. So, okay, there might be a different spot where we ask. Okay, so how do I even ask a question to this? How do I like? Is press .k to generate code? All right. Am I asking it a question like globally? Or anybody know how to use this thing? Not their website. Docs. Usage. So I believe I'm on a pro trial. Thank you, Cursor. Chat with code base. Command enter, start typing. Okay, so let's maybe start this file. Andre, good question. I don't know yet. I'm doing this in front of you all, hopefully with no ridicule to me, to figure that out. I don't know if it's useful. This also, I should mention, like, this is not my area of expertise in the whole Extism world. So a lot of this code was written by other much more capable people on our team than myself. So I'm kind of like trying to figure out if the AI can encapsulate some of that skill and knowledge, albeit, my estimate would be very in a limited capacity, and re-represent some of that back to me as, a novice in effect, about what to do and how to implement this. So I don't know yet. We'll see. We will see. Ankesh, good to see you. Try out composer mode and shadow workspaces. Those sound extremely advanced. I'm noob mode, and maybe I'll get there. But let's see. The log level set the host. So I can first check if the log level of the PDK user set should trigger an allocation for log message. I don't know this. Okay, well, that seems more useful. Kind of want to add everything. It generated something for me. Okay, so this seems like it's on the right track. Command I for composer mode. And shadow workspace is just an AI setting which lets AI agent shadow your workspace to get more Lint info. Maybe they're not advanced for you. I have admittedly been extremely skeptical of almost all AI stuff up until very recently. So I have almost entirely avoided playing around with most of this stuff. So not advanced to you, advanced to me. Um, but still, thank you for the pointer. I will look it up. I'm just going to see if, like, in this simple mode with their kind of entry point features, if this kind of stuff makes sense. So I do believe the current plugin. It'd be nice if I could actually like jump to the definition inside of their generated code, but that's all right. This could be where we want to store it. So when we create the new plugin, I want to set its log level, which seems to make total sense. We'll go with that. And then when we call its new method, which is where, we also want to pass okay, default, sure. Yeah, and this is telling me. Cool. Okay, so now we want to expose this function. Where is on level though? I don't think we have this. The host side code this call set log level when initializing the plugin. Yeah, that sounds right. Changes allow the plugin. Yeah, I agree. Ankesh has pointed out in chat the hype is settling. Reality is clicking in, and the useful stuff is sticking around. And I do have a feeling that this is like very useful stuff. I just haven't had a chance to really play with it yet. And again, like out of a stroke of luck, ended up having a kind of a free day. So I'm going to try to check all this out. Anybody who's tuning in now, please excuse me rambling, jumping around back and forth. This is the first time I'm using these tools, and I'm just trying to basically figure out if it can help me implement this feature to add a little bit of a allocation optimization to our runtime. So I basically just asked it, it had a moment to kind of take a look at the code. I'm not sure if it did a full ingestion or indexing of everything, but it seemed to do a decent job. And I'm trying to basically apply like a filter or a guard against an allocation that would otherwise happen needlessly if a log level is below the verbosity threshold that the host has set. So I see. Okay, so it is telling us to add a function, set log level, which is correct. We definitely didn't have that. And in the runtime, we can do this, but I think it's actually more important to do it in the PDK, and certainly we can do it in both sides. And why not? Let's just go ahead and do it. Oops. So inside log, we're going to check. I don't even know why. Oh, this is the wrong function. So yeah, this is where it would be helpful to be able to jump to this point in the file, because now I'm just kind of lost. Okay. That's That's still not it either. Where is this? What are you telling me to do? Let's just see if it gives me a diff here instead. Yeah, see, so I'm confused because this has visibility specifically limited to the crate, and this one doesn't. And is that me? Is that you? Okay, well, whatever. We'll accept it for now. Probably also already added this. Yeah. So, okay, this is going to basically take this kind of shared data between the host and the guest, which represents like the current plugin state, and some things that aren't exposed to like the user of the plugin, but the runtime has access to. And so this is just going to store a field for the level and move on so that we can then check this log level in the PDK down the line. Okay, so I'm hoping that there is at least one person from the team who works on Extism more deeply than I do, maybe watching this in the background, that can just like call out if I'm doing something terribly wrong. Okay, so then in libr, oh, okay, so you can jump. It's just not obvious. This takes you to the file. We did this ourselves. Let's just see if, why would we do that? That seems silly to add that there. Okay, whatever. Current plugin. Yeah, that's weird. This is not in this file, so that's kind of confusing. And then we need to finally wrap our function. And I don't believe this is the right module name, but we will find out. I know that we have like a little macro to handle some of this stuff. So let's save that, and then what is that macro called? Let's just see. Let's go. Okay. Hey, Spiro. Using Cursor for about a week. Not bad. As you expected it to be. Yeah, I mean, so far I'm not displeased at all by most of what it's done. Let's see if I just tell it like, okay, add the context. Like, why can't I just like add a whole directory of stuff? Just like whatever. Not args, add funcs. Possibly. Yeah, maybe. Yeah. Okay, so we added set log function. All right, let's just see. I'm going to try to get it to fix what it thinks I should do here, rather than using this approach. Let's first just see. So I don't think we use this func wrap directly. Yeah. Using this approach, as you suggested, find our used. So cool, it found this, and we want to add set log level to it. Does it have access to set log level? Perfect. Okay, so like I mentioned, like it was just going to use raw env, which is kind of the default namespace in WebAssembly to provide imports, which is like particularly, I think, co-opted from the JavaScript world, which basically says, here are the names of the functions that I want to link into the WebAssembly module when it's instantiated, so that the WASM code can call a function provided by the host. It needs a namespace. That namespace can be roughly anything as a string, and env was the one that it suggested I use, but I know, been around a while, we actually have a namespace that Extism uses by default to link host functions that we provide, and then also a default that links host functions provided by a host who wants to embed Extism on their own. So inside add funcs, I'm also terrible at typing, so just deal with it. We want to add set log level. So we're saving. This approach ensures the function is added to the correct Extism host namespace. Yep, and maintains consistency with the existing code base. The PDK set log level function would need to be defined in the PDK module, which we just did, but you don't remember. Cool. So recap, we added set log level into the runtime. There's a whole additional step here that we may not get to like convert our Extism imports into a C API for other runtimes to include. And so like the FFI from like the Ruby SDK, for example, exposes a set log level FFI function so that the Ruby code on the host side can call it, and then it makes its way over nicely into this Rust layer, which then provides access to a plugin. So that we might not touch, and we're already half an hour in, but it's cool so far. This is interesting. I'm going to just make sure I don't have any feedback on Slack internally about being cool. Okay, so we've set the log level in the runtime. We've exposed the function to the module name, the namespace, and what now? We also want to be able to like retrieve this log level. And so what I'm going to look at quickly is in our PDK. These are kind of just like raw, like straight up, like static kind of functions in this library. There's no kind of context attached to them. Obviously is just like the one plugin that calls these functions, but the only thing that has context of the plugin and any idea about state on the host side is the host itself. And so I think we will also need a function to get the log level from the host. And I'm just quickly verifying there's no maybe better place to just stuff that in the near term. Like Extism also has this really cool variables feature where I can set and read instance persisted variables that live beyond the scope of a plugin's function call. And so within a function call of an export, if you call, like set var with a key and a value name, that variable will be persisted between function calls, and also even across plugins that are linked together inside of an Extism manifest. So I can effectively share data between iterations of function calls as long as the plugin's alive, and that stuff will stay. So maybe we could use that. It doesn't really feel right just using that. I think I should probably just have a get log level. And so I'm going to basically repeat this same process and just say, let's add a similar function and expose it to the PK, which gets the log level after it's been set by the host and the runtime. It should also be a PK function, and I mean maybe just like it should return. I don't know. Should it return info by default? I mean, info is our default, and we're just going to leave it. So it'll be a PK function. It's available to plugins. Call run, so they can check if they allocate or not. Okay, so it's adding a global here. I don't want to do this yet. This is in the WASM itself. So we don't have a global log level. We don't have this kind of static atomic thing to use. I know. And so let's see, the implementation adds a get log level that retrieves a log. Yeah, okay, we don't have that to my knowledge, and you're not telling me to add it. It's just darn sure. Yeah. Okay. All right. I mean, I guess I can give it the excuse embeddings. What's going on? I like writing software, but man, I hate using software. Jeez, oh Pete. Let's just take it. Oh yeah, not the CI. All right. Okay. Let's just try this again. So like, we need a function. Maybe it's just on the current plugin to get the log level from the field it was stored on in the plugin data. This should look like the set log level you just added. Girish, thanks for joining. Nice to meet you. This, I think, yeah, YouTube records these. So they'll be on YouTube shortly after the stream. I don't know when this is going to end. And I'll try to kind of like annotate this based on where I make progress and whatnot. So you don't have to, you know, just wade through all the rambling. But yeah, it'll be recorded. You can check it out later. Thanks for asking. Yeah, okay, so this seems effectively what I thought it would be, and can use this method to retrieve current live level from anywhere we have the plugin. Okay, so great. We've got get log level, and where is set log level? New added log level, right. So little getter, let's just do it right here. Okay. Now that we can get the log level, we still need to expose a function to the PDK so that I can do something like this. These are like, this would be a very low level function call inside of the PDK. I'm trying to find something else that I can. Extism input length. Yeah, so like store U8. Let me just check a SQL here. Okay, so these are in the kernel. I may need to do the same thing here. I mentioned at the beginning of the stream, Extism also has this notion of a kernel, which is basically wrapping up a bunch of like host functionality that can be compiled to WebAssembly. And so you can see, where Extism, manages kind of memory for hosting guests, we can carve out that functionality of like, how do I copy memory from plugin operation into the host, and how do I like copy memory from the host into the chunk of memory that we've allocated already for the plugin to use. And the kernel basically implements this memory allocator and some other things. And so in here is where some of these things go that we may be able to grab the state of the log level. And that way, if we compile it into the kernel and we update the kernel into the runtimes, then all of the SDKs, except the JavaScript SDK, will get this feature just kind of for free, which is nice. What I don't know is if the kernel is really the place to go for this function, because this pointer we get here in these kind of functions or offsets expect to look at some memory, and we don't actually have the memory at the plugin. We want the host to tell us. So I'm going to move back into this file. And okay, so we implemented this. Right? Didn't we? Maybe not there. Where did we add it? Did we add it? We did. Okay. That's another thing, and this is, again, maybe just a me thing, but like I lose track of like where this thing is asking me to add code, and of course we've got Git to help, but surface it a little bit more. I think would be helpful. Take this for what it's worth, Cursor. I'm just a man staring at his computer trying to figure out what's going on. Let's see. Give me 1 minute here. Apologies. Okay. All right. So, okay. One other let's just to go back to this. Maybe I can copy this in as some context. So this is the PDK. This is the one that's written in Go to let Go plugins run inside Extism. I want to add effectively a check where we do log to say like, hey, get the log level set by the host, and if my verbosity is not is within the threshold of the setting by the host, then do this allocation. So I want to guard against the log level set by the host, and defensively allocate only when necessary. So I want to call a function in here that's provided by the host. And so I'm just going to see what happens if I say consider the Go PDK, where we call log and immediately allocate memory. Oh boy. And store log message. I want to be able to call get log level, which you helped me add in the PDK, determine if I should allocate. Here's the Go PDK with some imported functions. And we want to mimic such as Extism input length. Okay, so here is the first part of that. Here is the second part of that. Let's see what you do. Reading long file. Yeah, you and me both. Let me make a few changes. Add a new function. Yeah, here we go. So in PDK, we want to get the log level, and we've added this, which is brilliant. Okay, so where do we put this? Let's go. It looks good. It doesn't take any params, but let's just copy this comment. Get the log level params done. Returns. Okay. How do I use that? Cool. We like. That's useful. Fix it in chat. Fix it in chat, it says. Okay, I should extract this into something but that seems like a job for AI. Okay, so now I'm sure we want to export this in our func situation. Is it going to go back? Yeah, okay. Get out. Okay, so cool. Look at this. It's already preemptively helping me. What a guy. Okay, or gal. Get log level in add funcs, which is in plugin. Actually, not. Is it in here? You sure about that? You're sure about that? Okay, cool. I would accept the like maybe common wisdom by now that like you can just hit apply and like inject that function into the file. I don't know. Call me old fashioned, wanting to just like see the code in the file. I don't know. Maybe I'll get there. So this is going to go into the Go PDK, but not yet. Let's see how things are going build wise. You have a problem with this? Shouldn't have changed anything with this macro, so let's just, oops. Check that you didn't, because that would be, no, you didn't. Okay. All right, let's build the runtime, see how we're doing. Make sure there's nothing problematic, because we all know if it's Rust, so if it builds, it works. Yeah, let's just do a full build. Let's build the Extism. Okay, here we go. Get out of here. I feel like Cursor, if you're gonna take VS Code and make it into a better thing, you could leave out the stuff that doesn't make VS Code like super great, like all the constant nagging to sign into GitHub. Like, do you want to install 5 extensions relating to this file? I don't know. I'll look at the extensions. Okay, so weird. Oh, okay. I think maybe I did mess up adding. Let's just go ahead. Like see what you can do. Here's a possible fix. Give a macro invocation. Error is occurring because the issue is related to mismatch and expect the number of arguments for the get log level function. Oh, because we don't take any params as input. Yeah, I don't want to do that. You don't like that either. Let's just see if passing a arg here. No. What about PDK name do you have an issue with? I mean, this is the name. This is what you should be getting. application wraps the get log level function with closure. Yeah, I just you made it apply some changes to other functions. I mean, it's because this is an argument, like this is a part of the macro, the name. And then we have the args. This one doesn't have any. The space work. Might need Zach. Zach's the mastermind behind a lot of these macros, and this one's tough because this is just because func new does not take. It does that. Nah. Let's just read the error for ourselves. Collar, slice of values, and immutable slice of values. Okay. Let's go back to get log level. This one. And oh, I know why. We basically just need to provide it the same signature and then ignore these. And then yeah, this is still saying this one takes a pointer to the input, but I have such input here. Let's just try it again because I don't think this error popped up until we built. Expected. Oh, well, okay. So set log level, so get log level, we also need the output. So we got to write that value somewhere. This is excusable, I guess, on the behalf of the AI. So we need the output. And let's look at like HTTP status code, maybe. So yeah, we want to be able to set like the log level to the output of this function. Again, let's just see if this can do it. So instead of your suggestion, can you match the whole implementation to how HTTP status code works? I need an output param to write the log level and cast to the right type. Okay, what do we call it? The add func signature as well. Okay, there's been a few more folks joined. We're about an hour in. I kind of just like started a clean session with Cursor for the first time just to see how far I could take it, working in a part of the Extism runtime code base that I'm not super familiar with. For those of you who aren't all familiar with Extism, it's a WebAssembly plugin system framework that makes it super easy to embed a WASM runtime into your application of choice. We support like 16 different languages to run WASM code in, and then to compile the WASM code to be executed inside your app. So you can call like user code safely and write plugins and run those plugins. We have PDKs, which have a bunch of like built-in kind of standard runtime global functions that are available to the PDKs. And so right now I'm trying to include some functions that let the PDK more intelligently allocate or not allocate memory guarded by a decision where we're looking to see, is the log level set by the host, should I log based on that log level? And of course, we already have implemented should I log. It's now the question of, based on that log level set by the host, if the plugin says I want to do a debug log, if the host doesn't have a log level set that warrants writing that debug log, then let's also not even allocate the log message. And it has updated this function for me, which is cool. So so what we've done is now we're assigning to this output parameter, which is like the return of the function get log level, and assigning to its first parameter the numeral value that represents the log level. And we had previously asked Cursor through, looks like we're using Claude, to add this functionality to store and set the log level onto this kind of shared representation of a plugin as far as the host is concerned. So now the host is tracking what the log level is set to and how to then expose that functionality to read what the log level was set to the plugins through the PDK. And then this should now work, and cool, we've gotten rid of our error. So hey, congrats, Cursor. Thank you. Let's rebuild this now. Everything's saved. Yep, I think it worked. Okay. So, code compiled. That's a good start. Now what? Now we can. So let's also revisit this other side of the equation, the PDK. This is the Go PDK. This is what a plugin developer would use to try and write a plugin for an Extism host. And you could write that plugin in Go. You can write that plugin in like 9 different languages as well, Rust and JavaScript and Zig and Haskell. And let's just take a quick little glance here at all the options for you. Assembly script and .NET. This is C# and F# for all our functional friends in the house. C, and more are coming. We also have a experimental PDK contributed by Glenn in our community, called a language called Moonbit, which is really cool. Let's just give them a little shout out. If you want to go take a look at a new language that is targeting WASM directly and prides themselves, rightfully so, on generating just excellent, fast WASM code, check out Moonbit. Cool team from the people who made Reason ML or BuckleScript, or kind of like OCaml like JavaScript compiler. It's pretty cool. Where am I? Yeah, so the PDK, we want to be able to allow users to, this is the wrong thing, to call the log functions and, like I mentioned before, guard against the log level if it's appropriate or not to write the log, which we already do, but we allocate the memory for the log message preemptively, and we don't need to do that. Instead, we could do something similar to this. And yeah, so anyways, I think there's actually a little bug in that code anyway, so we can fix that while we're here too. Cool. Yeah. Anybody, anytime, if you have questions or thoughts, or you want to yell at me for doing something silly, just go for it. So this is done. I want to test this, and in order to test this, I need to run an Extism that uses this build. And so I probably need to create a Rust program to use this library directly. And in that library, we're going to want to, in that Rust program, we'd want to call our new set log level function, which I think will be hidden through some other wrapping at some level. I'm not going to worry about that right now. But I think we could do that. Because right now, I don't think that we have tests set up in this repo that will do a full integration, calling a plugin that's written in this repo too. So there's a lot of repo bouncing back and forth in this project, in Extism in total, just because there's so many languages and runtimes and compilers and all that stuff involved. So in the normal case, maybe we'll just do a little bit of additional background here because it's fun. libextism exists as kind of a container project that brings in all of the runtime code, as well as the functions that are provided as imports to the PDK code. And we create a separate shared object, shared library out of the runtime so that all this stuff can be kind of FFI linked into the host program. So if you're in PHP, or if you're in Ruby, or if you're in OCaml or C++ or anything that's not Rust, or Go or JavaScript, because those have their own runtimes, then you will link libextism. And we build libextism based on runtime code. There's also a runtime package, which if you're just using Rust, this is what you use. And we can pull this into a cargo project, and I can just reference this locally. So I think that's what we should do to test this out. Give me one moment there, just to check. Slack, because I am still working. Cool. All right. So let's just do also a quick little review here. Oops. If we were to run a plugin from Rust, we would bring in the Extism dependency. We should update that version. And we would write a little executable, a program where we load some WASM. In this case, this is a pre-built Extism plugin, our handy count vowels code. And it's pretty self-explanatory. It's going to count vowels of the input string that's passed to the plugin call. And we set this up by loading the WASM as pointed to a URL into the manifest. And the manifest kind of constructs the blueprint of how to link, how to allow certain host access if you're going to allow HTTP access for the plugin, which directories you may want to give read or write access to from the host mapped into the plugin, kind of creating a layer of indirection between a real file system and the one that WASM is talking to. And then lastly, with that manifest, construct the plugin. This would take some import functions if they were available, if you as a user wanted to provide your own custom imports. And then this true flag sets the WASI linking of WASI preview 1 imports into Extism. And then we would call it. And so this call is loading an exported function from WASM, and then for you, copying, allocating and then making available as input this string hello world to the plugin itself. And we call the count vowels, and it's going to return on this string that it counted 3 vowels and shows you the vowels that were used to determine the count. You can pass in other vowels if you'd like as config, but this is just kind of parroting back to you what the conditions were in order to determine that count total. So we could do something similar like this, and reference the Extism runtime locally at a path, not a version, and hopefully it'll pick up all the stuff that we changed. I guess we'll do like, can I do another cursor? Oops. That's the right program. New window. Yeah, let's just do it this way. Let's go. We'll call it like set log level. And Cursor installed a CLI for me, which is cool. And in here, we're going to, it's big, it's a lot of white on the screen. Sorry if anybody was hurt by that. We're going to add Extism. I'll just change the path in here. Unfortunately, it probably just loaded a bunch of stuff. Okay. That's sort of right, but I think I need to go to runtime. Let's see. I think. Okay. And then Extism, Rust, Steve. That's kind of fun. It's wrong, but it's kind of fun. Okay, so we don't have a plugin yet. We'll write that later. Maybe we can even just, you know what, let's just use this whole example. Because I want to make sure things are working the way that we think that they're working. And it's too big. We don't have any logging or anything to my knowledge in here, but the output should just represent the same we saw on the website, showing us this JSON. So if everything works as expected, we should just get that output. Cool. So this is just some WASM we have stashed up in a repo to test some stuff. Eventually, to test this properly, we're going to have to write a new plugin and compile it with that new import added to the module. We don't have that yet, but anywho. So let's open up the Go PDK. And we want to add a new import because the runtime that this plugin gets executed within, the modified one, which is built into now this program, should provide us a get log level function, and we should be able to use that to switch on and check if we should allocate. So, actually, maybe we do have it. Just plug in have a Yeah, where am I doing this? Set log. Okay, so there's one more thing I got to actually set. I got to set the log level when I initialize the plugin, and I have to put that somewhere. So I probably need like a plugin new with log level, or add something to the manifest, which would be a reasonable thing to do. Right now, it's going to default to info. And info, let's think. I could still test this and just write a plugin that uses something info or less verbose to check, sorry, less verbose than info to check that the memory allocation doesn't happen. And then more or equivalently verbose to info to see that it does. So yeah, why not? Why not? Has anybody else used Cursor or any of these things? Is Cursor like, it seems to be getting a lot of attention and people enjoy it. I certainly think it did a good enough job to start with, but is anybody else using anything else? Not that I would probably try something new right now, but it's just good to know. No. Okay, so I'm going to open up the Go PDK. Let's go. Oops. I just need to stash some changes here. Let's call this and Cursor open it. Okay. I also need to remember to like talk, not like whisper my thoughts as I normally do when I'm working. But you guys are all here listening to me, which I forget sometimes. So apologies. Where are my files? What are you? What's going on? There is everything. Okay. All right. So now in here, okay. So we've made some changes in the runtime, which is in a completely different project. Let me go PDK, and I think I'm just gonna like. I think I'm just gonna like copy a bunch of junk from here into the context and just hope for the best. Actually, I kind of only think I need these two. And we'll see how it goes. So in here is where we want to add the kind of raw, low-level thing, the function call from WASM, from the host that WASM will have access to. So let's say, considering the functions which this Go PDK will import linked from a WASM runtime. Please, because I'm nice, add support for them in both env.go as raw imports, as well as implementation code in Extism pdk.go, where the get log level function is called before we allocate memory to hold a message. You already generated, in fact, I'm going to say single function. We don't actually need set log level in here at all. And I might be able to remove that from the PDK or the add funcs macro, because the PDKs don't need to set the log level. They just need to log at some verbosity. So considering the function, already generated this notation, which I've also copied here. So excuse me. Let's take just this function. Come on. New import. Similar to, let's just call it like HTTP status code, and generated implementation, which was, oh boy, yeah. So, I mean, it kind of already did this, and maybe we should just copy this in, but let's just see what it does. We're here to learn. You gave me this. Generate implementation. Let's see here. What's it gonna do? So yeah, just gave me this. If there's anything log related, let's just put this up here. System get log level returns the current log level. Correct. You then, I think I already have this code. Oh. Current level. Yeah. Okay. I'm not going to do all of that. We certainly will take some of that. And then we'll also use our log memory wrapper. Yeah, I guess why not? We'll just use this. Log memory is just a lower level. If you just have raw memory, if you've gotten like a HTTP response back from the PDK util to make an HTTP call, before you read the body of that thing, the HTTP body and the full response is actually just stored in memory in a shared space between the host and the guest, so that you don't actually need to copy it into the guest and like pay the cost of an allocation to copy the memory in. So rather than copying memory into the plugin and then immediately copying it back through a log, you can just pass the memory itself as a reference into the log so that the host knows to do the lookup at the offset here and not bother copying it in and out of the plugin. So we're going to keep that low level thing there. However, we're going to change. And then trace, we actually are still adding back. We removed support for that, but we're adding it back. So we'll just keep a note here to include it. Cool. So we have a PDK that now checks before the allocation if the level is more or equal to the verbosity level. And just to make sure that this is accurate, because I think that we maybe have not done this correctly here. Because we're literally just saying if you are info. Oh, no, that's right. This is right. This is correct. Yeah, so this is just checking. Okay, so like if I'm log level info, that is greater than like debug or whatever. Okay, so we're just going to test this. I'm going to write a new plugin that uses this. And actually, I'm just going to do it in here. Maybe we'll just add a test. Let's do count vowels again. And we'll build with TinyGo. And does this use... What does this use? I think by default, this is going to use... Yeah. Yeah. Okay. I always have to remind myself how Go package module resolution works when you're dealing with like local packages. Cool. Finally, we're getting some spam on the channel. That's awesome. I think we've reached a certain threshold of visibility when you start to get some spam on the channel. I don't mind it. I'm not going to highlight it, but I don't mind it. So we now want to do some logging. And to do said logging, let's pick one of these. We have a bunch of exports here that we use just for tests, doing little round trips here and there. Let's pick a simple one. This is about as easy as it gets. Okay, we're using some vars. Let's just do, let's just log. We got some output. Yeah, that doesn't seem too bad to me. Maybe we'll do this at like a little bit of a more severe verbosity. So like this shouldn't show up if we have log level info, which is the default. But if we set it to warn, it should. And in fact, just to check that we have the correct default in place, we should get this log. And I'm going to prepend to this string something else like we got logs. And then if I build examples, or what is my big example? I'm going to build all these things again. And we just edited tiny main in count vowels. So we should have a tiny count vowels, which is new. And we'll copy this into our demo. And I think I can put it here. And instead of this URL, we'll say file and file tiny count vowels. Oh, that. Okay, so we should have a default debug info on this. And I believe we also need to set like a log output for where the log's going to go. And yeah, let's just write it to standard out. Let's just Can I have AI do this for me? Like, is this seems like an AI thingy? How do I ask it to do? How do I ask it to do that? Does anybody know? Can anybody help me? Ask. Can you make it so log level info writes messages to standard? Yeah. Oh. What? Oh. Maybe. No. I'm going to run here. We have an example of this in the Rust SDK. We have it here. I think so. We don't. We need that. We need that. Yeah, it takes a function as the first param, and then a filter, which is the second. So this is the first parameter. What do you mean? We were passing it to arguments. Okay, AI, step in. Oh. Okay. Okay, what the? Let me just go to the source here. That seems to be the only way I can understand everything. Go back. Yeah, this is a function, and f is a static line. Oh, it's okay. The filter is the second parameter. The function is just the message. Okay, yeah. What do we don't need to check this level here. We just need to straight up print the message. And this is going to be and then this is sorry, what? I forgot where we stashed this bad boy. Oh, not even be in this package. Where is this package? One moment. One moment. Oh, it's in tracing. It's in tracing, but don't we export that? What? Yeah, this is not there. I don't think so. Okay, we're going back to here. And this is the wrong spot. Plugin, current plugin. It's tracing level. Is this what we use? That must be what we use. Okay. So we'll go back and we will add this, I guess. We'll excuse me. It just wants it as a string. Okay. Do you let me do that here? Yes, you do. Okay, we're just gonna. Okay, so let's recap. We wrote a new plugin that uses the new logging. The default, because we don't have this exposed through the plugin interface, is to set new plugin instantiated log levels to info. We are going to copy that to set our log level to info here. So we should see our log. It should print it out to standard out, thanks to print line. And then we're going to call our plugin function, which is still count vowels. Is it count vowels? What do we do? We exported count vowels and we log. So yes, it is the count vowels function. And we're going to try that out. We're going to try that out. Let's run it. No log. New logs. Let's say I don't see it. Let's make sure that we are pulling the latest Extism. Yes. Yeah, I don't know. Do not know. On one hand, the plugin is instantiating, and it wouldn't instantiate if we didn't have our host function. Let's just do this really quickly. Quick plug. The Go code that we compiled to WebAssembly should have in its imports listed a function called getLogLevel, and we can verify that using a handy little tool the team creates called ModSurfer. And we have in our Extism host env a getLogLevel function. Okay, so the runtime stuff worked. We have this function available to the plugin code, because otherwise this plugin would fail to even load to begin with if all of its imports are not satisfied by the linker. And we're using it. We're actually calling getLogLevel because most compilers will do a dead code elimination pass on the WASM as an optimization. And so if you actually aren't even using getLogLevel in your code in some line of execution in the actual instructions, this is going to be eliminated and will be removed from the import table just to be kind of clean. So yeah, when we call count vowels at some point in there before we set the output, we should call get log level. But it doesn't seem to be so. It does not seem to be so. Anybody in chat has ideas, thoughts, concerns, questions, please let me know. Thanks everybody for sharing this on Twitter. X helps to see folks are interested in this stuff. Let's see. Quick check-in. Yeah. Okay. So yeah, it's also funny that we detect this and it says C was not. This module should have a producers section, which includes the compiler that was used to produce it. And TinyGo actually uses LLVM once it does its own kind of bespoke front end pass on the Go code. So TinyGo will, I think, actually leverages some of the standard library and the Go compiler toolchain to do some of this work, but it produces an AST after some Go tooling takes over, and TinyGo then converts that into LLVM-IR, whereby then the LLVM toolchain takes that code and lowers it to WASM instructions. And in that process, it may lose the producers section, which is a custom section inside the WASM. In fact, we might be able to check it out. Yeah. Okay. So we're hitting these hints. Producer section is a like pseudo standardized custom section in the WASM binary format. And the WASM binary format can contain all these custom sections, and they're for anything. You can stuff whatever you want in there. You can stuff programs inside of custom section for a interpreter inside of the WASM to run. You could just load text that you can look up statically, which is kind of how this tool works. It pulls out this producer section, it checks what's the language used, and it is catching Clang in this process by field before it sees TinyGo. So in our code that does this heuristic detection, we should definitely see if more things match before we make a decision. Because what ultimately this should do is, this is actually kind of cool. It gives you a nice little badge that represents this same thing. And let's see if let's just post it here so you'll have a little reference. It gives you a cool little badge. So if you share this on Slack or on Twitter or something, you get, should get this cool little unfurled thing. So like when the link gets loaded, we make a call into the mod server database and get all the information about the module and then like render this dynamically. And so the source language should be Go, but our detection hit Clang, as the producer pointed out, which indicates C. So file that as a bug. But anyways, cool to show that off. I'm feeling like I'm nearing the end of my tolerance for waiting on AI to write me code, and probably just want to go dig into this on my own. So it feels like a good spot to maybe wrap up the stream. Thank you all for following along as I stumbled through. Can Cursor help me do this? I think the answer is yes. I believe this added, some speed to my output to write this. And granted, I was also being somewhat conversational with the stream as I was doing it. So maybe not the best test, but hey, in what has it been, an hour 45, I think we got the feature implemented. Now I just need to kind of test it, debug a tiny bit. So yeah, I don't know. I'm more bullish after doing this than I was going into it. Thanks for the free trial. Everybody gets a free trial in Cursor right now, so I'm not special or anything, but still thankful. And I can see this being really, really helpful. I mean, this again, this part of the code where we were in dabbling in the runtime is not a place that I have spent much of my working time on Extism, and it got it, except for a couple little minor things, particularly around the function signature for getting the log level or setting the log level. I forget which one. Um, it getting the log level. Remember, it failed here. This one, yeah, where it didn't realize these in and out params were used to basically like realize the function call and say, here are the parameters that get actually passed to the function, and here are the parameters that are used as output, and then to write the looked up value from the log level stored on the plugin to use as the output value. So, you can't blame it entirely for that, even though there were a ton of references to this inside the same file. But, whatever. It's getting better. I mean, as they say, right? This is the worst it's going to be today. This is the worst it's ever going to be. So, keeps getting better, and I think I'll probably keep using it for some things. So, anyways, thanks again for following along. I will post a link to YouTube where this is kept, and maybe I'll post it on like the different tweets that went out to share that we were live, and maybe on Twitch too. So, anyways, have a great week, and I'm gonna do another stream on Thursday. To actually spend more time on Mod Surfer, which is kind of like an unsung hero of checking WASM code statically and applying policy to it, so I can ensure that this code doesn't have things that I don't expect it to, or that it does have things that would otherwise lead to a runtime failure, and a bunch of other things as well. And maybe also kind of see how we implement Mod Surfer to do things for us in XTP. So Thursday, I think 10 a.m. Pacific. Be there, be square. See you later.